Good morning, everyone. And how are you all this morning? Okay. This morning, we will be discussing one particular layer of the atmosphere, and we will be discussing the ozone layer. Very, very important to our Earth, very important to the world, and to us human beings. So we have the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. Three main things that the atmosphere does for us. Can anyone recall one of them?
It keeps the harmful UV rays from harming us.
Okay, that's a specific atmosphere. That's a specific one, but it is a part of the entire region. Okay, in the atmosphere, recycling of water, recycling of gases. Which main gas is that? That's one of the main reasons for the atmosphere.
Water vapor.
Water vapor, yes. Okay, for us to have a moderate climate, the atmosphere also, it has what is called the electricity and magnetic. It has this force that all of it works to make sure that the Earth has a moderate climate, all right? And the last one is that it absorbs energy, the energy from the sun. Okay, three main functions of our atmosphere. As we go along, these will be reviewed. Elements in the atmosphere. These are water vapor, water, argon, carbon dioxide, neon, helium, methane, hydrogen, ozone, nitrous oxide. We're going to do the activity where you use your bubbles. Now, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 1, 2, 1, we'll call 2 groups here, 3, 4, 5. Now, you're going to blow bubbles. So make sure you have a container in front of you. Please pull it in front of you. And we're going to call the names of these elements. We need to remember them. We need to remember them. So we're going to call the names of these elements. Let's give an example here. Let's hear Carl and Leticia. Let me hear you loud. Say the first one.
Water.
Thank you. So get ready to blow your bubbles. Share them around. Get ready. Ready. 1, 2. Blow. This is your time. You can enjoy it. When you blow, you say water because it's going up. Try it again. 1, 2, 3.
Water.
Next group.
Carbon dioxide.
Good. We're not finished. Methane. Okay. Let's continue.
Hydrogen.
Okay.
Ozone.
All right. We've just reviewed the names of those elements in our atmosphere. And when they all go up, the evaporation happens. What happens in the atmosphere with all these elements? What occurs? When they go up, they're going to spread out. They're going to spread out, and it becomes the atmosphere as a thin layer of gases. Isn't that so? All over us in the atmosphere, right? Which help to shield and protect us. Now here is a beautiful picture of the stratosphere. We are going to be talking a little bit more in detail about the stratosphere.
The planes fly in the stratosphere and the balloon air.
Okay, specific planes. Specific planes. What are they called? Not just any ordinary plane. So the planes that we fly to go to the United States, would we be flying in the stratosphere? We'd be flying Yes, we'd be in the troposphere. Okay? Blue jet, specific, very specific. And there's the ozone layer. There's the ozone layer that we will be talking about. What's the altitude? What's the, from the bottom going up to the top? What's the altitude of the troposphere according to what is given? Cal?
10 to 50 kilometers.
It's up to 50 kilometers, yes, and it starts around 10, just above the tropopause, and it extends up to 50 kilometers, about 31 miles. Notice we have what is called the polar stratospheric clouds, and we will be discussing that in a little while. The stratosphere by Mia Lee Dunkelberger. Dangerous, but yet amazing, wonderful filled, important, and beautiful. The poet expressed herself and relates the love that she shares for others. Why do you think Mia refers to the stratosphere and her love as dangerous? According to her, the stratosphere is compared to the word dangerous. She describes it as dangerous. Take a guess.
I would say because of the heat that the stratosphere.
Very good. I would agree with you. All right? Amazing. Let's go back to the picture. Amazing. What's so amazing about the stratosphere? Do you agree it's amazing? I believe it is.
It's altitude?
Yes. Yes. Okay? Very good. Let's look a little at what it says about the stratosphere then. The stratosphere is a layer of the Earth's atmosphere. It is the second layer as one moves up from the Earth's surface of the atmosphere. The top of the stratosphere occurs at 50 kilometers or 31 miles altitude. The boundary between the stratosphere and the mesosphere above is called the stratopause. The altitude, which means the height, the altitude of the bottom of the stratosphere varies with latitude and with seasons occurring between 8 and 16 kilometers. So it says that what happens in the stratosphere, you will have varying seasons and you will have varying altitude. The bottom of the stratosphere is around 16 kilometers. And you will find in the mid latitude, it's about 10. And near the poles, where it is closer to the poles, it actually goes to 8. There's a part that seems to be about 16 kilometers. And then in the middle, it's going to be about 10. Closer to the pole, it's at 8 kilometers. And you will see the significance of that later when we talk about the ozone hole. All right? Bear in mind that when it comes near the poles, it's around 8 kilometers. It is slightly lower in winter at mid and high altitudes. So it is said that the temperature and the altitude will vary in seasons. In the winter, it will be lower. So what do you think will happen in the summer? It's going to go higher. Good. It is slightly higher in the summer indeed. The boundary between the stratosphere and the troposphere below is called the tropopause. The stratosphere is very dry, so there's little vapor up there. As a result, it says clouds are rare. Do we understand that? Because what happens when we have clouds?
In the stratosphere, it is very dry, and in order for clouds to form, you need water vapor, and if it's dry, then water vapor can't exist there, so it is very rare for you to find clouds in the stratosphere.
Okay, it's rare. There is a little, those same clouds that we saw, but it's rare. It's not a lot, okay? It says that the stratosphere contains 90% of Earth's ozone. Ozone It can be good and it can be bad for our health and for the environment. And it depends on its location. Let's take a guess. The bad ozone, where will we find it?
Stratosphere.
It's in the stratosphere. So we can say that the stratosphere has the good ozone. So let's take a guess. Where will the bad ozone be? Where is that? Stephen? Farther? Not really, but thank you for trying. Come on.
The troposphere.
The troposphere. All right? So let me ask again. Where will the bad ozone be found?
Troposphere.
Thank you. Correct. Let's find out a little bit more about what it says then. It says that we know that ozone occurs in 2 atmospheres. It occurs in the troposphere, which is called ground level, and it occurs in the stratosphere. In the troposphere, ground level or bad ozone is found. This is harmful to breathe and it damages crops, trees, and other vegetation. So the ozone found in the troposphere is not good for the surface of the earth. It damages crops. It's bad for our breathing. It is harmful to us. And what makes up most of this ozone? Can you tell me what you believe urban smog is? What is urban smog? Edwin?
Urban smog is smoke and fog that are mixed together, usually in cities because of the pollution there.
Yes, city pollution. Can you give me one example of a city pollution? What would cause city pollution that would cause smog? Erwin?
Factories.
Factories, thank you. In Belize, if we talk about smog in Belize, what happens on the street daily? Go ahead, Erwin. Think about what we see.
The driving of cars.
Yes, vehicles, all right? Ozone is a molecule composed of 3 oxygen atoms. There are some words I would like you to remember here. The interaction, the breaking apart, and the hitting of ultraviolet radiation. Okay? What occurs in the atmosphere? And now we are talking specifically about the stratosphere. We have these oxygen atoms that form the ozone. When we talk about oxygen, we write the symbol O2 because it reminds us that oxygen consists of 2 atoms, right? Now, when we say ozone, we use O3 because of how it's made up. Most ozone found in our atmosphere is formed by interaction between oxygen molecules, and ultraviolet radiation hits oxygen. What will happen that the atoms will break apart from that molecule. So you have the entire molecule of oxygen, the ultraviolet radiation hits it, and because of all the interaction, they break apart. What happens after that is that these single atoms, these single oxygen atoms will go back and they're going to combine themselves again with the oxygen 2. Single oxygen atom combining with the oxygen 2 along with the ultraviolet radiation is ozone. So if we ask which gas makes up ozone, what is the answer? It is oxygen. It's oxygen. Oxygen interaction with the ultraviolet radiation combined with single atoms will cause ozone. And this continues over and over. And so over many years, we believe in millions of years, the ozone layer exists, continues to exist. Scientists tell us that ozone is rare. That's what the scientists are saying. They say that it's rare. It says that the average ozone is about 3 molecules for every 10 million air molecules. Just think about all of the atmosphere, all of in the stratosphere. And here we have the ozone layer. Do you think then that the ozone layer makes up a big part of the stratosphere? Yes or no? How many of you say yes? No. And we agree with you. We can look back at that and see that layered part. Let's look at it. See there? Right in the middle there is the ozone layer. That is the part. Of all the millions, that small part there is the layer of the atmosphere. In spite of all this among, the ozone plays a vital role, and it is very much needed by us and Earth on the surface there. Now let's go to what is said about the polar stratospheric clouds. Earlier we saw them, we viewed them in the picture. It says common above the poles. Remember when we talk about the altitude and the surface, we said that the stratosphere around the pole area, what is the altitude?
8 kilometer.
8 kilometer. So, common above the poles in the winter, the clouds play a major role in depletion of stratospheric ozone. So it's the same polar clouds that has to do with the damaging and the depletion of the stratospheric ozone. In the winter, the temperatures of 80 degrees below cause chemical present in the stratosphere to freeze out and form polar stratospheric clouds. Now, when clouds are formed in the stratosphere, it is not good. Not good for the ozone layer, because that is what causes the depletion of the ozone layer. These ice particles provide the surface for the release of chlorine. So it's what actually in the clouds we have what is called chlorine monoxide, and that is more specifically what depletes the ozone that we'll hear a little bit more about in just a while. Chlorine reacts with ozone to form chlorine monoxide and oxygen. It says above the clouds we have major depletion due to the stratospheric clouds, the polar clouds. And then it says that this happens during the winter. So we have these clouds, and in the winter time there's a release of chlorine. The same chemicals that go up, they release. So, and they form chlorine monoxide. And on that surface, that is where this all happens in the winter, and then it releases, and that affects the ozone. The Industrial Revolution. Have you all ever heard about the Industrial Revolution? Erwin?
I think it's when the humans or the society began, like they got a major leap in building stuff, something of that nature.
The words used there, major leap. Very good. Very good. Edwin, would you like to continue? Very good start there, Erwin.
The Industrial Revolution is the time of which humans had an outbreak of different technology, and they started discovering fossil fuels, coal, and they started using these fossil fuels, which started polluting, and they didn't know what it was doing to the atmosphere.
Very good, right? We hear now about fossil fuels. Very good, right? This happened in the later part of the 18th century, 1830, 1850, and after. There was this, what was then called technology. industries being built. They move from, transportation moved from animals like horses, and cars were being manufactured. Many buildings were going up. Many of the goods were processed in factories. What people began to eat were processed in factories. It is said that at that time, people became rich and life got easier. But this new revolution gripped the world, and we were not ready for it. Why do you think it is said that we were not ready for it? What was it that we were not ready for?
We weren't ready for the consequences and the responsibilities that we have to
Thank you very much. Very good term. Consequences. It was all about the consequences that came after this great revolution of industries. It's the consequences. This revolution was an economic one which changed the ways by how the world produced its goods. So people then felt that it was better to eat a canned food rather than eat something that was planted and we were able to get from our farm. On the technology front, the biggest advancements were in steam power. And we know we talk about fossil fuel. New fuels such as coal and petroleum were incorporated into new steam engines. And can you imagine these steam engines and all of the traffic and all that is happening? What's going up in our atmosphere at this time? While our world progressed, what was going up? Harmful gases. Thank you. The Industrial Revolution was not a good revolution for the planet. From the time it started, the factories and industry has increased the amount of carbon dioxide in the atmosphere. And while the carbon dioxide was being increased in ascending into the atmosphere, we were doing something else related, that we were taking away more carbon dioxide from our earth also. What was going on at the time with the industry? It was mentioned before. Leticia, you want your house, isn't that so? And so many houses went up and many buildings and a lot of businesses, and people started to travel. So there was another depletion. For building, people were using, for all the development, what did people need to use for the development? Trees, okay? Taking away carbon dioxide also. In our drive for consumerism, our planet's natural resources are being depleted at an alarming rate. Pollution by nuclear waste, pesticides, and other chemicals are also the result of industrial revolution. So along with that progress and what we knew as a good life, the beginning of a good, rich life for many people, there came pollution and all the other things. And there came the ozone layer's hole. The ozone layer is believed to exist many, many, many years. Scientists will tell you thousands, millions of years. But the first theory was presented in 1930 that scientists said, you know what? We are sure that there's a layer in our atmosphere, in the second atmosphere, that is protecting Earth. That was the theory given. In 1985, the Halley Bay, a British research station, discovered and reported the ozone hole over the Antarctica. Do you see the relation with the polar clouds? The altitude there, it says that it's lower in the winter, it's lower by the poles, talking about the stratosphere, and now here, when the depletion began, it began in that same area. The areas that we know have more experience of cold, of winter. Isn't that so? All right. Now, this research station is what I would compare to what is being done here. Do you know, and I will tell you what I've learned about this station, do you know that in this station, technology right now is predicting climate for the next 30 and 60 and 90 years? Do you know that is happening right now in this station? In this center? Oh, Edwin said up. Yes. So, like how we have a research station here, there was this research station being sponsored by the British. And there was this man who was Mr. Halley. His title was Halley. A scientist. In 1985, he discovered that there was something called an ozone hole. Not specifically a hole, but there was scarcity in certain areas, and they termed it ozone hole. This alerted scientists that humans had a significant impact on the global environment. What does that mean? They were alerted that humans had a significant impact. Why did humans have a significant impact? Think about what we just discussed before. In what ways, or what way did human have a significant impact on the ozone hole, the depletion of the hole?
Humans assisted in the depletion of the ozone layer because
Very
of
good,
all the
I like that.
gases.
Humans assisted. Another word we can use, humans caused it to happen. And that's why it will take humans to change what is happening. This prompted much research into the causes of the ozone depletion. In 1930 also, 1930 seems to be very significant. Man-made CFC, and we'll find out what is CFC. Compounds were developed for industrial and commercial use. CFC, chlorofluorocarbon. And we'll find out what makes those up in a short while. Now, after the Industrial Revolution now, along came something even better. We found out that there were some products. Now, because of all the pollution, scientists started to, and the people who did all the chemistry started to look at what can we do now to safeguard our health so we can breathe better. We can use things that will be safer in our homes. And so CFC compounds were developed. In 1970, these CFCs and other chlorine substances were suspected of having the possibility of destroying the ozone. We started to use all the CFC products, and then in about 40 years, they found out that they were actually contributing at a very high level to the ozone layer. These products were non-toxic, non-flammable, non-reactive. And if we knew these products, they were always marked just like it says, non-flammable, unless you put it by a certain heat or a certain place. When you use them, you didn't smell them. Let's look at all the CFC products. Let's send up the CFC. Stephen's group will be 1, Alexander 2, Edwin 3, Daisy 4, and then Carl 5. Let's name these products that are contributing to the ozone layer and its depletion. We need to hear you all. Come on. 1, 2, 3. Let's get the other group.
Pills.
Again, the next group.
Carbon tetrachloride and methylchloroform.
Lastly, heaters, swimming pools, aerosols, cleaning cleaning detergents, all these things that made our lives so easy, they smell so good. They allow us to have our refrigerator and our air condition and a cool car while we're driving. All relates to the CFCs, okay? The ozone is found in 2 regions of the earth. We heard that before, and it reminds us now that there's 90% of the ozone in the stratosphere. And we're reminded again that the ozone is what we call, consists of 3 atoms. We are also reminded that they have different effects on humans and other living beings, and that we have stratospheric ozone, the good ozone that is beneficial. And while all this is happening, we have the depletion going on. It absorbs biologically damaging ultraviolet sun. That is what the ozone does for us. The absorption of ultraviolet radiation by ozone creates a source of heat. This forms the stratosphere itself. And it says that ozone plays a key role in the temperature structure of the Earth's structure. So ozone helps to determine the Earth's temperature. So what happens that the ozone absorbs the ultraviolet radiation. Let's say that we do not have the ozone, or what is happening with our ozone layer, what's going to happen to us here on the surface?
The earth will generate more heat, and that can cause a lot of deaths.
The earth generates more heat. Edwin, you may add to that.
It is causing global warming for the same reason that Kyle mentioned.
It is causing global warming. Thank you. Without the filtering actions of the ozone layer, more of the sun's ultraviolet radiation would penetrate the atmosphere and would reach the earth. And that's what Kyle and Edwin just mentioned. Many experimental studies of plants and animals and clinical studies of humans have shown the harmful effects of excessive exposure to ultraviolet radiation. Let's take some guess of how it affects us. What are those harmful effects that have been shown or have been observed that has been happening to people in general? Because it has been occurring.
Skin cancer.
Okay, that's a good example. Let's continue. Okay, how does the depletion of good ozone affect human health and the environment? Ozone depletion can cause increased amounts of ultraviolet radiation, which is true for skin cancer, cataracts. Have you heard the word cataracts? Okay, cataract has to do with a white skin that grows over the eye, right? An impaired immune system, so it even affects our immune system, which makes us more vulnerable to cancer. Overexposure to ultraviolet radiation is believed to be contributing to melanoma, and melanoma is said to be a skin cancer. Listen to what is said here. Since 1990, the risk of developing melanoma has more than doubled. If it has more than doubled, what does this mean to human beings, or what is being said about human beings?
It's telling us that there's a higher risk of catching the cancer.
Thank you. There's a higher risk of getting skin cancer, and more so because it has doubled. It means that there are more people. It is telling us that more people are getting skin cancer. According to data they have on people with skin cancer, it has doubled. More people are being affected. Ultraviolet radiation can also damage sensitive crops. For example, soybeans, and reduce crop yield, so lesser crops. Some scientists suggest that marine phytoplankton, even the plankton in the sea. So even our coral reef and the algae that lives in our sea, even those are being affected by ultraviolet radiation due to the depletion of the ozone hole. This stress could have adverse consequences for human food supplies from the ocean. Is that so? Is that so? Yes. Because those are the marine phytoplankton. Those are what the animal species depend on a whole lot. And so if you have the breakdown of any kind of thing like for food and the food chain, then you will have humans being affected because we depend on these for food. Troposphere ozone comes in direct contact with life form, is very destructive. And high levels of ozone are toxic to living systems. Studies have shown harmful effects of ozone on crops, forests, and or human health. In the troposphere, the ozone, it has been affecting our breathing. Do you know anyone with sinus condition? Have you heard about sinuses? Okay, asthma related to that. Okay, here is a picture of the ozone layer. It shows you the stratosphere, and the picture also shows you the troposphere. Notice what it says at the top. Too little here. Where we see the ozone layer, it says it's too little. Yet, we know that it is said that it's too little, but how much percent of the ozone is in the stratosphere? 90%. How much in the troposphere? 10. But yet, the 10% is too much. The 90% is too little. Because we need that 90%, we need that to absorb the ultraviolet radiation. But the 10% is too much. Why is it too much? The 90% given in the stratosphere for the ozone layer is not enough. Why? Because we need all of that to absorb the ultraviolet radiation. Yet the 10% we have in the troposphere is too much. And it tells us why it is too much. Let's all read what it says together. Ready? Too much here. Cars, trucks, power plants, and factories all emit air pollution that forms ground-level ozone, a primary component of smog. Okay? Too much. The dual role of ozone leads to two separate environmental issues, and I would like you to please pay attention to what it says about these roles. One, the first concern is that the increase in ozone in the troposphere. So there's a concern by the scientists that ozone, because of the practices of pollution, increases in the troposphere. The smog is a familiar problem in the atmosphere of many cities and around the world. Do you believe that Belize has a problem with smog? To a high level or to a low level? How many of you say a low level? How many say a high level? I believe it's a low level because we do not have so many factories. Edwin?
The bad ozone, if those molecules are the same are those the same type of molecules in the good ozone in the stratosphere?
The same type?
If they're the same type, because
yes.
If they're the same, then what is stopping those the bad ozone molecules?
Okay, we're going to, you have a very good question, and we're going to explain that in a short while. Okay, so hold that thought and we will get to it. Here, I want you to sit back and enjoy this video.
There was a time when the warm glow of morning filled this old body of mine with joy. But now, the sight of each new dawn just fills me with concern. The sun is a cauldron of blazing hot gases. For more than 4.5 billion years, its heat has kept us alive. But along with that warmth, there lurks a hidden danger. Deadly ultraviolet rays, or UVs, that can harm all life on our planet. Luckily, we're protected by a brave little band of defenders at the very edge of space. The ozone molecules that make up our planet's ozone layer. Despite their tiny size, our ozone defenders are amazingly strong and smart. They let in the sun's life-giving warmth, whilst keeping out the deadly UV rays. And things might have gone on this way forever, were it not for a new threat rising up from below. Chlorofluorocarbons, better known as CFCs, are the chemicals that cool our air conditioners and refrigerators. CFCs are safe inside their machines, but once they escape, they begin a 25-year journey up to the top of the atmosphere, where they attack the ozone layer without mercy. And once the ozone molecules have to fight the UVs and the CFCs, it's just a matter of time until the ozone layer weakens and breaks.
What? Who are you?
Alberta Albatross, my little friend. And who might you be?
Ozzy Ozone. Pleased to meet you, Mum. But tell me, please, what above Earth is going on?
Let's go and see. The chemicals that attack you are CFCs. They've been used in man's machines for over 50 years, and they're quite safe until they are let out. When the developed nations realized these chemicals were dangerous, they replaced them with new ozone-friendly products. But some countries, like this one, still cling to the bad old ways. Pesticides like methyl bromide can be just as dangerous. And industries aren't the only ones to blame.
No! Oh, this is terrible. We must stop them, Alberta.
We can try.
Excuse me, sir. Sir, over here. Sorry to bother you. But don't you realize you're releasing dangerous chemicals when you break those old refrigerators? Those molecules you release go up into the sky and cause trouble for all of us. So please don't do it again. UV warriors, watch out! Please don't be afraid. We only want to protect you.
fire extinguishers use halon molecules that also attack the ozone layer.
He got that nasty burn because chemicals like the ones he just released are destroying the protective ozone layer we've created at the top of the sky. And it's not just sunburns we're trying to prevent. UV rays wrinkle your skin and make you look much older. They cause cataracts on your eyes that can lead to blindness. And they can weaken the body's natural resistance to disease. Even worse, while your bodies are growing, little ones like you are particularly in danger because UV damage now could give you cancer later on. Don't be scared. This is serious business, but there are ways to defend yourself. Protect your skin by covering your arms and legs. Wear a hat to protect your face. Sunglasses to protect your eyes. And sunscreen for the rest. Stay indoors when the sun is high. And always try to stay in the shade.
And ask your parents to make sure that their old refrigerators and air conditioners are disposed of by approved technicians, specially trained people who won't let the CFCs escape.
It's important, not just for you, but for your children. Because even if no more bad chemicals are released into the atmosphere, it will take at least 50 years before we can fully repair the ozone layer. Will you help us? And now, Alberta, after all I've seen down here, I'd like to get back to work.
Be sure to tell your parents, teachers and friends about the things you've learnt.
And don't forget, boys and girls around the world can make a difference. Because when it comes to protecting the environment, every action counts. Thanks for everything, Alberta.
Thank you, Ozzy.
Don't forget, boys and girls around the world can make a difference. Because when it comes to protecting the environment, every action counts.
Ozzy Ozone is begging us. Okay, just a recap. High amount of surface level ozone are increasingly being observed in the rural areas. There is widespread scientific and public interest and concern losses of ozone in the stratosphere. Ground-based and satellite instruments have measured decreases in amount of stratospheric ozone in our atmosphere. The Dobson unit is one such instrument used for measuring that. 1, 2, 3, 4, the CFC problem. It says CFC are released into the stratosphere. Remember, I want you to bear in mind that it's the CFCs, all those chemicals relating to the CFCs, okay? Carbons related to carbon specifically and chlorine. Those are the ones that are affecting the ozone layer. And we'll go back to Edwin's question in a short while. And it says that atomic chlorine destroys the ozone. Increased ultraviolet rays reach the Earth's surface, raising the risk of skin cancer and other dangerous consequences because of the depletion of the ozone layer. Edwin, would you like to ask the question that you asked before we end this lesson?
I wanted to know why don't the bad ozone molecules don't rise like the same like the others, the good ozone molecules, because since they're the same, there must be something stopping them from rising or something.
In the stratosphere, that's a natural occurrence happening. The ozone layer existed all the while, okay? So the good ozone in the stratosphere, it's we who are now affecting that. But what it says here on the ground level of bad ozone, it says that it is not emitted directly into the air. It's created by chemical reactions between oxides and nitrogen oxide. Okay? It's the chemical reactions of things like you talk about the fossil fuel and all those things that has the effect on the bad ozone, that causes the bad ozone, and volatile organic compounds in the presence of sunlight. So what is happening here is different from it's what is happening in the stratosphere. And the ozone in the stratosphere, as I said, is a natural occurrence. But the ozone there that is in the troposphere actually has to do with our bad practices. Now the depletion is also because of our practices that we did not know was bad. We had comfortable things that we were using, and later we found out because of the chemicals that they were made of, those were specifically affecting or impacting the ozone layer. All right, you have a little card there, and before you leave for your break, kindly state one item. Ozzy mentioned several, and you may have another one. And so now I would like you to state, you identify and state on your card one item that we may use that is hazardous to the ozone layer. Let's see if we can recap what Ozzy said, or you may think about something else that we use that may be related to the CFCs. When we return, we will be talking more about the CFCs. You need to mention one, write it nice, write it well, very clear on your paper, and you may add a little border to it to make it attractive. We're talking about the CFCs. Dangerous, it's causing the depletion. Hazardous means that it's dangerous, it's a part of causing the depletion, okay? Could you write it with a marker so it can be clear? Bright. Remember, in the troposphere, we create that bad ozone, right? Due to the practices, especially of pollution. And remember, for the ozone layer, it is specifically the CFC products. It's a brain teaser. Let's have some volunteer to share. What do we use that is hazardous?
Some people still use some fire extinguishers that contain harmful gases that go up and damage the ozone layer.
Some people use?
Fire extinguishers.
Fire extinguishers, yes. Do you know what is in a fire extinguisher that is one of the CFCs that is harmful to the ozone? Very good, Erwin. Do you know what's in there? Okay, it's helium.
We use vehicles which emit carbon monoxide.
Okay, we use vehicles which emit carbon monoxide, right? Another answer? Somebody else to share theirs?
Smoke from factories.
Smoke from factories. Is that more affecting troposphere or the stratosphere?
It is affecting the troposphere.
The troposphere. Very good. Okay. Anybody else?
I also wrote fire extinguishers.
Fire extinguishers, correct. Okay, that's good. Earlier we heard about the depletion of the ozone layer. And we heard that it's the CFCs, those processed chemical products that we have been using, that they have been very friendly to us in that they're not toxic. We have found out that while these are very good and we use them and we need them, scientists found out that these same products, based on the chemicals that they're made from, are going up into our atmosphere and are destroying the ozone layer in the stratosphere. These CFCs are made up of fluorine and chlorine and carbon. And they have been widely used by people around the world. They have been used for decades. Now, these CFCs don't break down. It doesn't harm us because they don't break down. They're not flammable or they're not reactive to us. They will not harm us when we breathe and we're using them. But at the same time, it is said that they are a curse to the stratospheric ozone. They have now become a curse to the ozone layer. It happens that CFCs were found to be in use from even right after World War II. That would be in the 1940s. The ozone levels sometimes drop up to 60% now that the CFCs are being used. We're going to find out though, because of good practice, already we have been moving towards making a difference with the ozone hole. It says that the ozone levels there in the troposphere, sometimes it drops up by 60% depending on the season, the weather, and the other environmental factors that relates to the ozone hole. Over the United States, as well as the rest of North America, Europe, and Australia, ozone levels have fallen 5 to 10% since the 1960s. That's relating to the ozone hole. Who found these CFC products? It was the scientist in 1928 by the name of Thomas Medley, a very intelligent man, we believe, who came up with these friendly compounds that they were used to process chemical products that we could use that will not damage us. CFC is used in refrigerants, cleaning agents. So, can you tell me the main reason for placing your food in a refrigerator?
To prevent spoilage.
To prevent spoiling, yes. It helps your food to last a longer time. It preserves your food. So the CFC is a chemical used in the refrigerators for the cleaning to keep your food in order. Before we had the refrigerators, how would we preserve those food?
They use some sort of technique with salt and
salt, yes.
Salt and the sun.
Was salt and the sun. Today, we have our refrigerators. All we need to do is place it in there, and they have become very much more affordable. So think about this. What happens in a morgue?
A morgue is used to keep and preserve the dead bodies until their funeral.
I would like to share that the CFC is also useful for a morgue. Okay? It's used in the morgue. Before we had morgues, for example, the one we have at the hospital, what would have happened to a dead body?
I know of some tribes that would use a technique that are used for buccan meat, or they would dry the body out, dry out all the fluids. So
Yes, like what they used to do with the Egyptian mummies. Okay. Yes, they preserve the body by taking out all of the organs, and then they would put it on a certain process to dry it out and to embalm it, right? Okay. I would also like to share that even in the surgical ward, the chemical that is used to sterilize those instruments are actually CFCs. Compound, okay, used in the hospital, in the surgical ward. So can we say that these CFCs are important, but they're causing damage? Do we understand that? Okay. CFC is used in refrigerants for cleaning, as a cleaning agent, propellants and solvents. All the aerosol, those things that we spray, they're called aerosols. It was most commonly used to expand foam to make plastic and foam cups. CFCs play a big role in the destruction of the ozone layer, making this chemical harmful to everyone. The radicals from the chlorine destroy the ozone, therefore having a big impact on the environment. Here is a look at some aerosols that contain the CFC chemicals, okay? We see something there marked spray paint. We see an ant killer. We see glue. Paint, yes. Okay. Are they familiar to us? Do we have them in our homes? Yes. Okay. Refrigerators, automobiles, and air conditioners. Cleaning agents, foaming agents, propellants for aerosol sprays. So I asked you to write what was hazardous to the ozone layer. State one item that we may use that is hazardous to the ozone layer. Did you mention any of these? Okay. Some people mention fire extinguishers. Those also consist of the CFC compound, okay? The chemicals, right? Now, do we have a good idea of what these CFCs are? Can we name a few?
Body spray.
Body spray. Okay. Kyle?
Spray paint.
Spray paint. One more. Go ahead.
Pesticides.
Pesticides. Edwin?
Lysol products.
Yes. Yadira said pesticides, like what we saw the ant killer there. Mitigation. Mitigation, it says, means to make something that is bad less severe or less serious. Since we began these lessons, we have been discussing mitigation. What we will do and how will we do it to make such things that, like global warming, which is bad, to make it less severe or less serious. Along with mitigation, we must also adopt new practices. What does mitigation mean? Let's say it together. Something bad, less severe or less. Thank you. I'd like you to open your activity book to number 10. The Montreal Protocol on Substances that Deplete the Ozone Layer is a landmark international agreement designed to protect the stratospheric ozone layer. The treaty was originally signed in 1987 and substantially amended in 1990 and 1992. The Montreal Protocol stipulates that the production of consumption of compounds that deplete ozone in the stratosphere. Chlorofluorocarbons, halos, carbon, tetrachloride, and methyl chloroform are to be phased out by 2000. 2005 for methyl chloroform. Scientific theory and evidence suggests that once emitted to the atmosphere, these compounds could significantly deplete the stratospheric ozone layer that shields the planet from the damaging ultraviolet radiation. There were some leaders, and I believe scientists with them, who decided that something must be done. We must take action. And so mitigation was discussed. While we can't stop it immediately, we can put some practices in place that will help to make this serious effect less serious, less severe. The United Nations Environment Program, UNEP, has prepared a Montreal Protocol handbook that provides additional details and explanation of provisions. Can you give me one statement that was read in your own words? What was this Montreal Protocol about? Erwin.
It was set up to protect the stratospheric ozone layer.
Thank you very much. Would someone like to add another statement to that?
It was a treaty or an agreement with all countries to help protect the stratospheric ozone layer and
Thank you.
reduce the harms of them.
Very good. Okay? And it was specifically to make sure that something being practiced would stop, or countries around the world would start to understand the impact that this product or these compounds have on the ozone layer. What specifically was this compound that they needed to discuss and they made agreement on?
CFCs.
The CFCs. We call all of them, we put them in one thing and we call them the CFCs. Okay? That's how it's easier to remember them, the CFCs. Okay. Now we look at a chart. CFCs were developed as ideal gases used as refrigerants for refrigerators. Now, it says that uses of chlorofluorocarbons were for refrigerants, automobiles, air conditioners. Please remember these, students, they're important. Cleaning agents, foaming agents, aerosols. Let's go now to a chart. This was what came out of the discussion in the Montreal Protocol. Let's look at the chart. It says the change of controls by the Montreal Protocol for developed countries. There were decisions made for the developed countries and there were the decisions made for developing countries. Where would Belize fit? Erwin? In the developing countries, right? Now if you notice that if you look across the green part, you're going to see when the protocol was adopted in 1987, and then they went back into meeting. They had a London meeting, they had a Copenhagen meeting, they had a Vienna meeting, they had a Montreal meeting, and a Beijing meeting. So leaders and scientists continued to discuss. And the main thing was, we're going to phase out those chemicals and we're going to find more friendly chemicals for our ozone layer, for less depletion. One that came out of that was the HCFC, hydrochlorofluorocarbons. Hydro, when you hear the word hydro, what does that mean? What does it relate to?
Water.
Water. So it means it was like an alternative, a toning down of the CFC. Now, if you look at the phasing out, you will see that there were some decisions made. For example, the CFC and halon, those were, it says that in the London meeting, after the first protocol was adopted in 1987, it says in the London meeting, those were to be phased out from 2000. From 2000 complete phasing out, from 2000 complete phasing out. And so you have, for example, the other CFC and the carbon tetrachloride. You have another thing there about phasing out again. If you look at the tetrachloroethane, that one has to do with phasing out for 2005. You will see different years. They didn't say, okay, this is 1987 and this is 1990 and we need to do this now. They had to be, it's going to be less severe, and as continuously they will look for those friendly products that can replace the CFCs. Now those were the developing countries. We could look at the last one in Beijing. If you notice there, 1999, we have dates of 2004 for phasing out for different CFCs, and we have dates of 2002. But I want you to notice the difference when we get to developing countries. CFCs were going to start in the developing countries, which includes Belize, in 2003. And they were supposed to be phased out by 2010. So if we were using anything there, then by 2010 we should have been able to start to buy those products that were most CFC friendly. Halon, that was to be phased out by 2010. Carbon tetrachloride was supposed to be phased out by 2010. Methyl bromide is supposed to be phased out by 2015. And HCFC is supposed to be phased out by 2030. Should it be phased out? Yes. What do you notice about this one? The hydrochlorofluorocarbon. What year is it? 2030. Remember I said this was then used as an alternative to the CFCs. Okay? So now this is supposed to be phased out too. But because this is a calmer one, this one now is less effective as this one when it comes to the ozone layer. This has a longer time to be phased out. It still has an effect on the ozone layer, but it has a lesser effect. Now, if you look there at the developed country, they were more serious about starting the development, the phasing out in the developed countries. They had to begin first, and they were supposed to be completed before the developing countries. Why do you think that they gave them that kind of pressure, Erwin?
They are already developed and they have like an upper hand other than the developing countries that are just coming up.
You made a good start. They are already developed and they have the upper hand. Can somebody add to that?
That means they use much more of those products than the other developing countries.
Very good. They use much more. Who makes them?
The developed countries?
The same developed countries are making them. What I have here, are we making these in Belize? But we buy them and we use them, isn't that so? Okay, it's the same developed countries that are making them. And so they use them much at a higher quantity than we do. And so let's look at the time now, the time frame. Okay, the Copenhagen meeting. It says that they were supposed to start from 1996. It says complete phasing out, 1996. Now, when is all phasing out due? 2010. What they did, they gave the developing countries at least 10 more years. Now, from out of all of this, the agreements from the Montreal Protocol, this is what is being said. It is believed that if the international agreement is adhered to, the ozone layer is expected to recover by 2050. How old will you be by 2050? Grandpa? Okay, but remember, mitigation, less severe, and so it continues to be worked at, and work on until we have done better with global warming. Are we understanding that? Okay, so can we be hopeful, students? Yes, we can be hopeful, but now we will have to do some adapting. Adapt to new practices and principles. And in your lifetime, you will be able to share in that joy when the scientists can say, you know what, we've gained back our ozone layer. It is hoped that by 2050, it can happen. Due to its widespread adoption and implementation, it has been an example of exceptional international cooperation. What does that mean? Exceptional international cooperation. What do you understand that term to be? I'd really like one of the girls this time to answer. Thank you, Erwin. I'll come to you very shortly. Girls, share in the discussion. Exceptional international cooperation. What does cooperation mean? Do we cooperate? Unite. International. What does international mean? All the countries. Exceptional.
All of them accept.
Accept. Yes, that's a part of it. Very good. Isn't that so? So it says that it's very good cooperation with countries all over the world, and that is very good. This agreement has been ratified by 197 states at the European Union. So 197 countries or states have said, we agree and we will work with that. And today I would just like to share these with you and say, even in Belize, we're buying CFC-friendly products. Can you just look for the CFC-friendly label and pass it around quickly? Just look, share it with your friend and pass it around. I want you to take 2 minutes and discuss with your peer, discuss how can we do better. Now leaders are saying we must, and they agree on this, but now how we, individuals. And it is important as you look at the CFC-friendly symbol there, to remember to look for them when you go and you buy your groceries with your parents, or when you're sent to purchase certain items. Look for them and make sure that you're a part of the Montreal Protocol Agreement. I only want, at this time, one of your thoughts from each group. How can we do better? Let's hear from the first group. Erwin is representing there.
While recycling, we reduce a lot of the production from industries, since those are the major producers of CFCs.
Okay, recycling. All right, recycling. Very good. Let's hear from another group. Kyle's group.
You can use more electrically powered equipment such as motor vehicles instead of using gas that emits all the harmful gases into the air.
Okay, so Belize needs to get some electrical vehicles. Okay, right? It's true. Let's continue. Another group, Adita.
Less burning of fire.
Less burning
Of fire.
of fire. Okay, good practice. Yes. Use less CFCs. So when you go to buy now, you will look in for products such as those that say CFC friendly. Very good. Okay. Carl wants to share again.
You can use solar powered equipment on your house, for example, stove.
Very
you
good.
can use it to get the heat from the sun.
Very good. Okay. Now sit back. This one is short. Now you have another video and a short discussion after that.
Have you noticed our climate is changing? And when we say climate, we're not referring to day-to-day changes in weather. We're talking long-term trends. Changes that you can only see over a long period of time. Like shorter ice cover on lakes, warmer average winter temperatures, longer summers, more frequent heat waves and flooding from severe storms. These changes in climate can be difficult to see as we go about our daily lives, but they are important because they impact our communities, economy, and culture. The way we live is based on the climate we live in. Warmer winters means less ice fishing, snowmobiling, and cross-country skiing, all vital parts of our culture and economy. Longer summers mean farmers have a longer growing season, but more bugs and diseases to deal with. Heat waves may be nice if you're on the beach, but they can harm vulnerable people like the elderly and young, or those who don't have access to cooler places. And flooding from heavy rain can destroy homes, roads, and crops. As our climate continues to change, impacts are becoming more and more serious. And even if climate change is not impacting your community now, it will soon. But how and when we react, though, is up to us. We can adapt, which means we change the way we live based on how our communities are being impacted. If flooding is a problem, we can redesign stormwater systems to handle more water. And we can plant trees and crops suited for longer, warmer growing seasons. We can plant vegetation to provide more shade for cold water trout streams, keeping the water temperatures down. And we can develop heat emergency action plans to assist vulnerable people during heat waves. Adaptation, identifying and preparing for the impacts of climate change, helps in the short run and can save property, money, lives, and even wildlife. But in the long run, if we are to slow climate change, we have to curb emissions of carbon dioxide and other heat-trapping gases in an effort to reduce global warming. This is called mitigation. Small steps like driving and flying less, decreasing energy use, or reducing consumption are all examples of mitigation. But if mitigation of climate change is to be effective, it has to be on a large scale, which means we have to reduce harmful emissions as individuals, as communities, as businesses, as states, as countries, and collectively, as a world.
2 points that grabbed your attention. Let's hear from the middle group.
Adaptation.
Adaptation. Very good. All right. I have a few points here on how we can do better. And some of these were mentioned just before the video. Decrease uncontrolled releases of high temperature steam moisture to the atmosphere. They said that even if you're boiling water, being a Saturday, he had to rise up earlier. And so he decided to make himself his coffee. Now he doesn't need to fill that kettle. How many cups of water do you need? You need about half. You said 1.5? Less than 1.5, because when it steams you need to give some for evaporation. Isn't that so? Boils. Okay. So eliminate production and release of known ozone depleting chemicals, CFCs and HCFCs where remotely possible. Where it's possible, we need to practice. Remember, mitigation is making more progress, less severe until we have it completely in order. Subsidize production of safer alternatives where possible. So where we don't need to use them, we don't buy them. Establish controls to assure that new compounds to be used in high volume are researched for effect on the ozone. So when new products come in existence, we must make sure that enough research are done on these so we don't have the impact of what CFCs brought to our world. Try to use products which are labeled ozone friendly. We just look at at two examples, two samples being shared around. Ensure technicians repairing your refrigerator or air conditioner recover and recycle the old CFCs so they do not release into the atmosphere. Now, do you know what is in that refrigerator the CFC that can go up to the ozone? What do we call it? That makes it cool and clean? The Freon. Okay. Have you seen Freon coming out of a refrigerator or a car? Have you ever experienced seeing that? Hands up if you have. I've seen Freon released from a car, and I've seen Freon released from a refrigerator being bored by a knife. You will not smell it, but it has a song. It just gushes out. I've seen that happen in a car. Have you ever experienced seeing Freon being released? Kyle, have you? And doesn't make you feel frightened when you see all of that being released? It comes with a lot of pressure. It's just like when you're spraying a can, a lot of pressure, and it's far more than just one of those cans that we viewed just now, right? Now in Belize, there's a law. Let's say, for example, that this air condition would go down. And let's say that the technician has to come and repair it. The technician must have a machine that he captures the Freon, so he can recycle that Freon. The Freon should not be released in the air. That's a law in Belize now. Are we working on the mitigation? Yes, we are. Vehicle air conditioning units should regularly be checked for leaks. So you need to check your refrigerators, you need to check the vehicles. We have to make sure that these things are not being released in the air, because we know where they're going. The CFCs are going up to the stratosphere. Try to use products which are labeled ozone friendly. Ask about converting your car. Kyle said this just now. Converting your car to a substitute refrigerant if the AC system needs major repair. And that Kyle said about using an electric engine. Isn't that so, Kyle? Over the gas engine, the engine that works with the gas. Help start a refrigerant recovery and recycling program in your area if none already exists. Replace helium fire extinguishers with alternatives such as carbon dioxide. Didn't we hear that carbon dioxide is bad in the atmosphere too? Why would carbon dioxide be an alternative for CFCs? Erwin?
Maybe because it causes less damage.
Less damage. Anybody wants to add to that, or would you like to continue?
I think because using carbon dioxide, it extinguish the fire quicker, so you use less rather than using CFC products, which would take longer.
Yes, and another reason, where is carbon dioxide coming from? Us. Okay. What takes in the carbon dioxide? Trees. So if we plant more trees, then our environment will be a little bit more friendly. Isn't that so? Because then we'll have the trees to take in that carbon dioxide that is being released. So carbon dioxide, while it's not good, it is said to be an alternative, if we can, for CFCs. Okay? All right. One more for you. This time your activity will be increase awareness of the problem of depletion of the ozone layer and initiate a local action. You're going to work in pairs, and I would like you very boldly use this card, and I would like you to make one suggestion that your school now, you're going to send this message to your school. One suggestion for your school that will help in your school to increase the awareness. One for two persons, kind of share it around. it may have been occurring already. You may want to state that same one, or you may want to give an idea to your school. Your school can increase awareness of the problem of depletion, or it will initiate a local action. So one practice then, if I can put it simply, one practice that can be put in your school. You will advance now that awareness of the depletion. I would like to ask you to please discuss the message. Are we ready? Yes, you are. Kindly sit up. And then please use the mic and speak boldly so we can get the message across clearly. Group 1.
Have each class plant a tree in the schoolyard or somewhere. Do community service such as cleanup tasks and house-to-house visits, educating the society about global warming and how they can help.
Thank you. Alexander, your group will be number 2.
Assign each classmates to post up safety signs.
Very good. Group 3, Steven's group.
Safety tips. Turn off all lights and fans when not in use in class.
Thank you. Very good. And I encourage you to take it back to your school. Group 4, Kyle's group.
Do environmental projects, for example, planting trees and also using less CFCs.
Thank you. Very good. Take the message back to school. And Edita's group.
Do a cleaning campaign.
Thank you. Very good. Which could be a start. It could be the beginning of a good program. Isn't that so? Okay, and my last message there is less pollution is the best solution. It is the way on for our mitigation practices. Less pollution. So all that you said relates to less pollution. Is there one other point that one person would like to share before we end?
We should start or continue finding alternative sources that we can use other than harmful products that we are using now. So
yes,
it
we can continue. He said we can continue because we have started. And your presence here means that we have started. And the practices and beliefs we have started. So we can now continue the mitigation practices to make global warming less severe, less impacted on our earth. Thank you. Give yourselves a hand for being so.